Hi everyone, in this video what we're going to do is figure out what the limit is as x approaches 0 of tangent of x minus x divided by x cubed. Now, if we were to just let x tend to 0, in the numerator we would have tangent of 0 minus 0, which is just equal to 0, and in the denominator we would have 0 cubed, which is also just equal to 0, so our limit is of indeterminate form 0 over 0, and in order to solve it we're going to have to apply something called L'Hopital rule to it. L'Hopital rule basically says that if you have a limit as x approaches some value c of two functions f of x divided by g of x, this limit is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x, given that f and g are both differentiable at c and that the limit is of indeterminate form 0 over 0 or plus or minus infinity over plus or minus infinity. That criteria is satisfied for this problem up here, so let's go ahead and use L'Hopital rule to try and solve it. We're going to have the limit as x approaches 0. The derivative of tangent of x is just secant squared of x, and the derivative of x is just 1, divided by the derivative of x cubed is just 3x squared. Notice that we can rewrite this as the limit as x approaches 0 of tangent squared of x divided by 3x squared. Now if we just let x tend to 0, we have the same situation as before, that is we have an indeterminate form of 0 over 0, so we're going to have to apply L'Hopital rule again to try and solve this problem. Doing so, we have the limit as x approaches 0 of, now the derivative of tangent squared of x is just 2 multiplied by tangent of x multiplied by the derivative of tan of x, which is just secant squared of x, divided by the derivative of the denominator, which is just 6x. Again, if we just let x tend to 0, we're going to have a limit of indeterminate form 0 over 0, as tangent of 0 is equal to 0, and anything multiplied by 0 is also 0. So let's apply L'Hopital rule for a third time and see if we can solve this problem. We're going to have the limit as x approaches 0. We're going to have to use the product rule to take the derivative of the numerator. Doing so, we have 2 multiplied by secant squared of x multiplied by secant squared of x plus 2 times tangent of x multiplied by 2 times secant of x multiplied by secant of x times tangent of x divided by 6. Now if we just let x tend to 0, this term here is equal to 0, and secant squared of x times secant squared of x is equal to secant to the 4th power of x. And if we evaluate this at 0, it's just equal to 1, so we're left with 2 divided by 6, which is just equal to 1 over 3. And that is the final answer to this problem. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe, as it really helps the channel out. I hope you have a great day.